All right, so for question 5.2, we can also use the Statevector class in the quantum info module to simulate circuits and obtain the state vector. Given the following code, which option produces a different state vector from the rest? So let's go ahead here and first run this piece of code, right? So let's copy this and paste it down here. Now this is going to throw an error because we haven't imported quantum circuit. So from Qiskit, import quantum circuit. And as you can see here, we're also importing the whole quantum info section of Qiskit as QI and also NumPy. So let's go ahead and run the circuit up. Let's also go ahead and draw it, actually. So it's just a Halmer gate on qubit 0 and a CNOT gate on qubit 1. So we know that this should give us an equal superposition of 0, 0 and 1, 1. So it's the state 1 over root 2 ket 0, 0 plus ket 1, 1. We can derive this, but I believe we did this already in one of the videos for section 1. So let's not spend too much time doing that. So instead, let's just go ahead and see what state vector we get from this. So the simplest way to do this is, well, let's define, let's call this psi 1. And let's do, well, here we didn't import state vector, we imported the whole quantum info package. So let's do QI dot state vector, and we can just pass the quantum circuit. Before, back in 2020, you couldn't do this. This is a newer option in Qiskit, and if we draw this, as we said, we get 1 over root 2 0 0 plus 1 over root 2 1 1. So now let's look at our options here. So option 1 is this line of code, so let's just copy it and paste it down here and see what we get. And we can see we get the exact same result, and that's because this method from instruction does the same thing as just passing the quantum circuit here in state vector. So if you're passing a quantum circuit, what it's actually doing is running the same type of code that it will run if you use the from instruction method. So we're getting the same result here. Now let's take a look at option 2, where well, here we're pre-multiplying by 1 over root 2, and we're passing a NumPy array with the state 0 0, state 0 1 with 0 amplitude, state 1 0 with amplitude 1 over root 2, and state 1 1 with amplitude of 0. So this is definitely going to give us a different result. So if we run this, we can see this, that we get 1 over 2 0 0, 1 over root 2 1 0, not 1 1. So that's our answer right there. So it's option 2. But just to double check, we can run option 3, which is basically defining it using labels. So here we're creating the ket 0 0, and here the ket 1 1, and pre-multiplying by square root of 1/2. So that should give us the same result as expected. And then the last option is doing something similar to what we've done before. We're initializing the state 0 0 and then evolving it through the quantum circuit. I believe we used this quite a bit in section 1. So let's just run that and see that we get the same result. There we go. So for question 5.2, the answer is 2, which gives us a different result than the rest of the other options.